So, on 5.2, what we're going to look at is there's going to be three different things that we're going to do today. Two of them are very similar to each other, and realistically, I don't care which method you use. And then the third way, or the third thing, is trying to figure out if these are polynomials or not. The section is titled Evaluate and Graph Polynomial Functions. We're just going to look at the evaluating part of it today. The graphing part will wait till Monday. Okay? So, the first thing that we need to do is determine whether or not these things are polynomials. And on the top of page 337, they give you a definition of what a polynomial looks like. And a lot of that stuff, when you look at it, you might think, I don't know what any of that stuff means. Because it looks like this. It's got a to the n, x to the n, plus a to the n minus 1, x to the n minus 1, and so on. And it keeps on going on forever. All we're dealing with when we deal with polynomials is we're dealing with letters. You've already dealt with polynomials already when we had x squared plus 3x minus 7. That actually was a polynomial. You just didn't know it. It wasn't called that. We called them quadratics at that time because that was more specific. Okay? So there's going to be some things that we actually look at this, and it actually says a polynomial is a monomial or a sum of monomials. Monomial means one. Mono. Singular. Okay? All right? So that's what that actually means, and there's going to be some things that we actually go through and we actually classify them. On the top or towards the middle of page 337, there's a chart. And at the chart it says degree. Then it says type. And then it goes on to say standard form and then an example of it. Okay? Now, with a degree of 0, that means that I have no letters. That's what that means. That's also determined to be what they call a constant. An example of a constant would be if I were to have f of x equals 8. Notice how there was no letters in the polynomial side of it. The f of x is a function notation. That's what that stands for. That's just saying that it's that machine. Notice on the x part or the 8 part, there's no letter with the 8. That's considered a constant. When you do not have a letter with it, there's no variable to put in. That's considered a constant. When your degree is 1, they call that linear. And an example of that would be f of x equals 3x plus 7. Have you already dealt with linear stuff? Yes. You remember a long time ago, I think it was in like chapter 3 maybe, where we graphed lines? Do you remember when we graphed lines? Slope and y-intercept and stuff like that? That's a linear situation. Notice the exponent on the x is a singular 1. There's only a 1 in the exponent, and that's what it means by linear. If your degree is 2, that's known as a quadratic. You guys have already dealt with quadratics. Can't spell quadratic this morning. And again, that would be something like f of x equals x squared plus 3x minus 4. Have you, excuse me, have you guys dealt with quadratics? Yeah. In a couple different chapters you have. So none of this is new. Everything about this is still the same. You've dealt with constants, you've dealt with linear, and you've dealt with quadratics already. So none of that's different. Now where it becomes different is when we have a degree of 3 and a degree of 4. A degree of 3 is called a cubic. Okay? And all that means is the highest exponent is a 3. That's all it means. Okay? So when I have f of x and I have something like x to the third minus 7x plus 2, that's a cubic because the highest exponent is a 3. Yes, Alex?
Could there be an x squared in there?
Yeah, there could be. But I just didn't have room, so I didn't write one. All I'm looking at to classify it as a cubic, Alex, is what's the highest exponent. Okay? And then the fourth one is called, I better get this right, yeah, quartic. X to the fourth plus 4x squared minus 8, or something like that, as an example. Again, In order to classify it, all we're looking at is what's the highest exponent. Okay? Now, the first part of your assignment is going to give you a sample of one. And first of all, you're going to have to determine whether or not it's a polynomial. Then second, we classify it. And then you might have to find a couple of different things. When you're classifying it, whether or not it's a polynomial or not, the definition that they have here, it says a monomial or sum of monomials. It doesn't really say anything else like that. In our college books, it says a constant or a sum of more than one term, but they say where no exponents are negative. They actually add that in there as part of their definition. So what you're going to look at for the first third of your assignment is it's going to say something like g of x equals 7x plus pi x squared minus the square root of 3. And the first thing that you're going to do is you're going to look at that and determine whether or not that is a polynomial or not. I want you to look at the letters. Do any of the letters have a negative exponent? No. Are any of the letters in exponents themselves? No. So we are good. We are a polynomial. So I'll give you one that won't be here in just a second. So if it is a polynomial, what's the highest degree for this one? 2. Squared. So if I write this in standard form, I'm going to write the highest one first. And then go down from there. So if x squared is the first one, if I decrease that by 1, what's the next one? 7x. And what's the one that doesn't have a letter?
3 squared. Or not squared, but...
Negative the square root of 3. Okay, now, if you are going to label what they call the constant, which one does not have a letter? That is known as the constant. The one that does not have a letter attached to it is known as the constant. So if they ask you what's the constant, you put negative square root of 3. Then the next thing that they're going to ask you to do is they're going to ask you to identify the lead coefficient. When you put them in order, when you put it in standard form, when you put the highest degree first down to the whatever, they're asking for what number is in the front. What number is in the front for us? Pi. This is known as a lead coefficient because of the fact that it's in front of standard form. Now there are other coefficients in this problem. 7 is a coefficient, it's just not the lead one because it's not in front after you rewrite it. You need to rewrite it first before you can determine which one's the lead. Okay? Now I'm going to give you one that's not going to be a polynomial. Yes, that's all they're going to ask you. Oh, they also will ask you what type this is. What type is it? It's a quadratic. Because you said, and why did you know it was a quadratic? Highest exponent's 2. Right, good. That easy. Is this a polynomial? No, why not? Right? That right there tells me no. So when that happens, can you write it in standard form? Can you write the lead coefficient? Can you write the degree? Can you do all that other stuff? No, you can't. No. Here's another one that's tricky. If they give you 3 over x plus x squared minus 7 or something like that, that's also a no. Why is it a no? Because of this one right here. If you were to rewrite that using no fractions, you'd have 3x to the negative 1 because it's on the bottom. If you bring this up, it would be a negative right there for the x, and that can't happen. Another one that shows up sometimes is when they put 2 to the x like that. That's not a polynomial. When they have the x as an exponent, that's not a polynomial. That's exponential. That's something different. We'll get to that later on in this year. Okay? You just put no. All right, so if that happens, you just put no. All right, let me give you another one just because. F of x equals 5x cubed minus 7x squared plus 3x minus 2. Is this a polynomial?
Yeah.
Yes. What kind? It's a cubic. Why is it cubic? Because the highest exponent's a 3. What's the lead coefficient? 5. What's the constant? -2. Was it already in standard form? Yeah, I did that on purpose. What if it wasn't? You'd have to rewrite it. Okay? What do you think? This is your first third of your assignment. This is what you're going to have to do. It's only 3 questions for that. Huh? Kinda. All right. Then, the next thing that they're going to have you do is do something like this. It's going to say f of x equals 4x to the third minus 5x squared plus 7x minus 8, x equals 2. What they want you to use or do is use what they call direct substitution, and they want you to plug in the number 2 and see what you get. Have you done that before? Have you plugged in a number and see what you got? Absolutely. How many times have you done that in your life? Too many to count. So, 4 times 2 to the third minus 5 times 2 squared plus 7 times 2 minus 8. You're plugging in the number -2. When you plug in a number for a letter, please put it in parentheses, because what happens if you don't?
That'd be like 52.
Sometimes it might look like a different number, or if it was a negative, you might get the negative sign wrong, and then that's a problem. So, how do you do this? Some of you might just stick the whole thing in your calculator as it looks. Will it give you the answer? Absolutely. 2 to the third is 8. 8 times 4 is 32. 2 squared is 4. 4 times -5 is -20. 7 times 2 is 14. What's 32 minus 20? 12. 12 plus 14? 26. Minus 8? Did anybody type it in the calculator as is? Did you get the same thing, Cameron? Yeah. Weird. Okay, so if I ask you to use direct substitution, all they're asking you to do is plug the number in and see what you get. Can you do that? Do you want me to do another one? No? Me neither. Then there is a third way of doing this, or this next way. What, Alex?
So it says f of x, right?
Yep.
So what does that like mean?
F of x is function notation, and it means that when you have f of x or g of x or h of x or anything like that, those are nothing more than machines. They're different machines. And function notation is just a way to describe it. It's the same as saying y equals the.
So with different applications, it might come into use, like the g of x when you're about it.
Yeah.
So not that.
Right. Then the last part that they're going to have you do is what they call synthetic substitution. If you guys can figure out what I'm going to do right now with synthetic substitution, the rest of this chapter will be easy. Because there are going to be some parts that we use this for when we find zeros, when we divide. We do synthetic substitution or synthetic division so often in college algebra and in Algebra 2 like this for this chapter, that if you can figure out this today, it's going to make your life a lot easier later on. Okay? Same type of problem. 5x to the fourth minus 6x cubed plus 7x minus 2. And I want you to put x equals, Alana, give me a number. 1? Lame. All right. So, for you, some of you guys would be like, well, why not just put 1 in there and see what you get? And that is an option. However, I'm going to show you what synthetic division or synthetic substitution looks like, so that way when we see it later on, you won't be so surprised. The first thing that we're going to do is we're going to put the 1 that Alana told me to put in into the backwards L. Then on the next line down on your paper, you're going to make a nice straight line there. Now, the next thing that I want you to do is I want you to tell me the coefficients in order from their degrees, from the lead coefficient all the way to the constant. So what's the lead coefficient in this problem? 5. What's the next one? Now, I want you to leave a little space in between the 5 and the negative 6, so that way you don't think that you have to add or subtract them. Now, here's something that I want you to pay attention to, because this is a major part. If you screw this part up, you're going to get the problem wrong. Trust me. We went from x to the fourth, x to the third. What should come next? There isn't one. So, at times during the course of the year, right now Miles is missing, but graciously, you guys left his spot open for him. You notice that? Miles is actually downstairs with the theater stuff right now, and he is gone. Right? And nobody sat there. So that desk sits empty, but that's his spot holder, correct? Yep. Jordan is also gone. Him and his family went on vacation. Nobody sat in his spot. We have placeholders. Okay? What should I put in that spot where x squared should have been? So that there's a place for x squared, but it's not really there. A 0, not a 1. Because a 1 would mean that we have something. So anytime you are missing a letter, you need to put a 0 in its place. Make sure you hold a spot for it. I'm keeping his spot for Miles so that when he returns, he has his spot. We're keeping Jordan's spot because when he returns, he can sit there. Does that make sense? So I should go 4, 3, 2, 1, constant, but the 2 was missing, so I put a 0 in its place to hold the spot for him to say, hey, I know you're coming, but no one is going to sit there. What's the number in front of the x term? And what's the constant? Is everybody okay with the setup? Everybody understand the setup? Getting the setup done is half the battle. Now, here comes the process. The first thing that you do is you drop the first number straight down and imagine as if someone were swimming that doesn't swim very well, and he jumps in the pool and drops straight to the bottom. This guy. Okay? So I'm going to drop straight down to the bottom. That's what happens. So the first one gets dropped straight down. Everybody okay with that? Cool. Now I want you to take 1 times 5. What's 1 times 5? 5. Then you're going to insert that 5 underneath the next number. So 1 times 5 is 5, and I put it underneath the next number. Now, I want you to add straight down. What's negative 6 plus 5? Negative 1. Now, guess what we're going to do? We're going to repeat this process until we get to the end. So that means 1 times negative 1. Insert it under the next one. What's 1 times negative 1? Negative 1. And what's 0 minus 1? Negative 1. 1 times negative 1. Negative 1. 7 minus 1 is? 6. 1 times 6. 6 minus 2. 4. And I circle the 4. Now, your book calls this synthetic substitution. In most mathematical circles, this is also known as the remainder theorem. A theorem is something that can be proven. You guys should have known that from geometry last year. This has been proven over time that if you are plugging in the number 1 into your problem, the remainder, when you get done, is going to be what your answer was. So if I were to put 1 in for Alana's problem to begin with, 5 times 1 to the 4th is 5. 6 times 1 to the 3rd is 6. 7 times 1 is 7. Minus 2. 5 minus 6 is negative 1. Plus 7 is 6. 6 minus 2 is 4. I get the same answer if I do direct substitution as compared to synthetic. And you should. This is just another option. This process down here is going to be, we're going to do this about 4 or 5 other times this chapter alone. We are going to do this quite a bit. So if you can understand it now, it's going to make the rest of the chapter go really easy and smooth for you. Yes, Alex?
Okay, so you plugged in 1, and then it told you that the answer is 4, right?
Yeah.
That equals 4.
Yeah.
And that's what we know now.
Yeah.
Okay.
Absolutely. So 4 is the answer.
Okay, that's what you're
The answer to when I put in the number 1. If I put 1 in there, because that's what Alana told me to put in there, if I put 1 in there, I get 4. Now, if you were to pick a different number, Adele, like 4, we would get a different answer. But Alana picked that. So, okay, let me get him another one.
So we're just trying to find what equals? And
Yep.
what we did?
Okay, so what number goes in my backwards L?
Whatever number we want.
What number is it telling you?
Oh, 4.
4. What's the lead coefficient? 1. That started with x to the 4th. Then it should go x to the 3rd. Is there an x to the 3rd term? No. So what number do we put in its place? 0. Then we go x squared. Is there a squared term? No. So what number do we put in its place? Is there an x term? Yeah. What's the coefficient for x? 3. And then what's the constant? It's also important that you put the signs that are in front of it. So if it's a negative 20, then make sure you put negative 20 in there rather than just a 20. Okay. Is everybody okay with the setup? All right, now the process. Drop the 1 just like your favorite teacher was swimming. Then 1 times 4. Insert it, add it. What's 0 plus 4? Multiply it. What's 4 times 4? Insert it, add it. What's 0 plus 16? 4 times 16? 64 plus 3? 4 times 67. This is where you're going to actually have to use a calculator probably. 268 minus 20 is 248. Awesome. Now the one thing that I like about this one, and I've done some pretty big ones, you guys only have x to the 4th. That's the highest one you guys have. My college book, the highest one they have is like x to the 7th. Can you imagine x to the 7th? And if I were to ask you to put 5 in there, that would be 5 to the 7th power. That's a pretty big number, isn't it? So therefore, you'd be getting some pretty big answers and whatnot. The nice thing about this is the only time it got big was towards the end. And sometimes it doesn't even get big when you're multiplying the numbers. They're smaller numbers. Rather than the direct substitution. Substitution might get big. Yes, Alex?
So it gives you the problem, and it tells you that x equals 4, right?
Yep.
So why don't we just plug that in?
That's what we're doing, the same thing, just a different type or different way.
So we're just doing it in an easier way.
It may be easier for you, maybe easier not for others.
Okay.
It's just another technique for doing it.
So
Like, remember when we did quadratics when I said sometimes you can factor them, sometimes you can complete the square, and sometimes you can quadratic formula?
okay.
This is the same way. Sometimes you might want to put it in directly, and sometimes you might want to just use the synthetic division.
So we're not finding the x, it's given to us.
No, it's given to you, right?
We're just finding what it equals.
Yes, you're just finding what it equals. What do you think? That's the last third of your assignment. That was in your assignment, by the way. So it starts on page 341 and goes 4 to 22 evens. It was number 22 that I just did.